if we come to the next part, the two problems that's upcoming, they are a little simple, so therefore we haven't done on this, and we'll just go through how we can do this problem. In the 22nd problem, they gave us y as this determinant, f of x, g of x, h of x, L, M, N, A, B, C, where obviously L, M, N and A, B, C are some constants. So what we do in order to find, they ask us to find dy by dx, and they say that dy by dx is a certain quantity. So for that, what we do is, since it's given in determinant form, we expand the determinant, and as a result you're getting y. By expanding the determinant, you get f of x into m and c minus b and n, we know. So also minus g of x, L into c minus a into n, that we get it here. Last term, h of x is equal to lb minus ma, lb minus ma. Now what we do is, we have already got the y expanded like this. Now it's for us to get the derivative. They have asked us to take the derivative, so take the derivative on both sides. Derivative of y is dy by dx. We are going to take the derivative of this term. So we have to first take the derivative of this. Because this is a constant, this comes out. Derivative of fx is f dash x. Next term is this. This is a constant, it comes out. Derivative of g of x is g dash x. We have to take the derivative of this term. This is a constant, it comes out. Derivative of h of x is h dash x. But incidentally, when we write the dy by dx like this, it works out to be the determinant itself. When we expand the determinant, it's exactly this that comes up. So we are writing dy by dx in determinant form, and the determinant is this. So that's how it is. They have asked us to show the dy by dx. We have done it by expanding the determinants. So also the next problem, quite simple. They tell us that y is e raised to cos inverse x. They ask us to show a certain statement. So we show it by taking the derivatives. So what we do is, first for the given y, we take the dy by dx. How we get the dy by dx? We all know that e raised to x is e raised to x. Derivative is e raised to x. But if it is e raised to a fx, then in that case the derivative will be, suppose say if you have the function as e raised to a fx, then the derivative will be e raised to a fx into derivative of fx. So that we have to look out. So that's why we are taking the derivative this as it is, e raised to a fx as it is, and the derivative of this term, a cos inverse x. Derivative of a cos inverse x is minus a by root of 1 minus x squared. So this is how it is, and this is a turning point. Generally what happens is, people will do dy by dx, then they will find out d squared y by dx squared, then they will try to put it in this expression and try to show that it is 0. In some cases it works well, and that way you can do it. It's a correct method, but it's a long method. Sometimes it works fine, and sometimes you're able to do it fast, but sometimes it will create you will end up doing a lot of work. So at this step, you can be little observant, and you could do one thing. We realize that this term is as it is, but this term is y. So let's write dy by dx as y into minus a by root of 1 minus x squared. So also take this root of 1 minus x squared on the other side. So you're getting root of 1 minus x squared dy by dx is minus ay. Why we are doing this? Because we know we have to take the second derivative. And so as I told you, conventionally, rather than doing dy by dx d squared y by dx squared, if we are observant, because we see that this 1 minus x squared is required over here. So with that observation in mind, we are taking this term on the other side. After taking it on the other side, we take the second derivative. So we are going to take the derivative on this side and the derivative on this side. When we take the derivative on this side, it's a product. This and this, they both are functions, so it's a product. So we have to apply the product rule. So first, we keep root of 1 minus x squared as it is. Derivative of dy by dx, that is d squared y by dx squared. Next, dy by dx as it is, derivative of this term. Now derivative of a root is always 1 by 2 root. So that is why 1 by 2 root of 1 minus x squared. But 1 minus x squared itself is a function, so you have to write its derivative also. Derivative of 1 minus x squared is minus 2x. So that's how you get the derivative of root of 1 minus x squared as minus 2x by 2 root of 1 minus x squared. Of course, the 2 will cancel each other, and so we are left with root of 1 minus x squared d squared y by dx squared minus x by root of 1 minus x squared dy by dx. And on the other side, because we were left with minus ay, it becomes minus a dy by dx. So that's how it is. This is our expression. We just have to modify it and get the answer. We are done. We have to just modify it, get the answer. We observe that it is root of 1 minus x squared d squared y by dx squared minus x by root of 1 minus x squared dy by dx when we cut the 2. And on the other side, we are getting minus a into dy by dx. Now, because we always keep an eye on what we require, we plan to substitute the dy by dx. We already have the dy by dx is this expression. So we substitute that dy by dx by this expression. Because we don't have to, in the expression, we don't have dy by dx on that side. So we substitute dy by dx, and dy by dx is minus ay by root of 1 minus x squared. We make that substitution. After we make the substitution, throughout we multiply by root of 1 minus x squared. So this expression multiplied by root of 1 minus x squared, this expression, everything multiplied by root of 1 minus x squared. The root of 1 minus x squared is already there over there, and one more root of 1 minus x squared you have multiplied. So we always know that root a into root a is a. So like that, this becomes 1 minus x squared. The root was already there, one root we multiplied. So it became 1 minus x squared d squared y by dx squared. Because there was a root in the denominator, when we multiplied another root over there, it got cancelled. So we are left with x dy by dx. Same thing happened on the other side. There was a root in the denominator and we multiplied a root. So both those roots cancelled each other. So this is our resulting expression. In order to show what they have asked, we'll bring it on the other side. So we get 1 minus x squared times d squared y by dx squared minus x dy by dx minus a squared y equal to 0. That's all. That's how you prove the given expressions. We are done with the chapter 5 now. In the next, when we meet with chapter 6. Thank you.